talk about simplifying square roots in the past. We're going to dive a little more into them in this unit. So just for some review, in this first example, we're going to simplify each of the square roots. Some of you like factory, some of you like to do largest perfect square. We are going to do largest perfect square. You want factory. You should get the right answer. Just make sure you're checking up here. So when we do the largest perfect square, we're going to write the first 12 perfect squares. Well, all you have to do is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, your calculator. I'm going to write the list at the top of my paper. 1 squared is 1. 2 squared is 4. 3 squared is 9. What's 4 squared? 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 11 squared. And 12 squared. On 44. So, simplify, if we look at A, you try to take the square root of 63 in your calculator, it gives you a decimal. So that means you have to simplify it. So you have to figure out the largest perfect square that can divide into 63. Looking at our list, what is the largest perfect square that can divide into 63? Well, that's the one just under it. Does 49 go into 63? Well, go down to the next one. Does 36 divide into 63? Go to the next one. Does 25 divide into 63? Nope. Right to the next one. Does 16 divide into 63? Nope. Does 9 divide into 63? Yeah. How many times does 9 go into 63? 1 times. What's the square root of 9? 3. Can we take the square root of 7? Just out of habit, whenever we take the square root of something, what sign do we put? Just out of habit. So for B, what I like to do when I have a number and then a radical, I go straight to putting parentheses around that radical. Then focus on simplifying that radical. Is 36 a perfect square? Yeah, what's the square root of 36? So that 4 drops down, the parentheses drop down, and that parentheses becomes a 6. 4 times 6 is what? 24. And again, just for practice, one week old. Like using complete the square and things like that. Probably gonna have it when that looks like this. For C, what do you notice underneath the radical? A negative. So what can we take out? What happens to the number underneath? Positive. Very good. So then we have to look and see how can we simplify it. Is 18 a perfect square? Nope. So we have to figure out what's the largest perfect square that can go into 18. What's the largest perfect square? 9. How many times? What's the square root of 9? Can't take the square root of 2, so we drop it. What has to go in between the 3 and the radical? Don't bring it up. You took that out. And the proper way to write it is it goes in front of the radical but behind the number. Not like a variable. And again, just for practice. For D, simplify. I have a giant fraction underneath the radical. I like to break it up into 2. And then simplify. Well, if we look at the top, is 4 a perfect square? Yeah, what's the square root of 4? 2. Can we take the square root of 5? No. So we leave it. Right? That's what we've done in the past. We just left it. Right? Well, how the next section's talking about, in geometry, whenever we had a radical in the denominator, we couldn't have that. We weren't allowed. Okay? So that's what's going on this way. And in geometry, we talked about, especially when you do 30, 60, 90, or 45, 45, 90 right triangles, You cannot have a radical in the denominator. Okay? When you come across this problem, okay, so you can use the process called rationalizing. The denominator to get rid of it. So in the past, we just left it as 2 over radical 5. Now we know a process cannot have that radical in the bottom. Right? And that's what we're going to talk about here. After we simplified this, and the last example, we ended up with 2 radical 5. That's right. If I can take the square root of something at first, I'm going to take the square root of it. Okay? So we can take the square root of 4 to get 2. To get rid of the radical 5, all you have to do is multiply the top and bottom by whatever radical is there. So we have a radical 5 in the bottom, we multiply the top and bottom by radical 5. And then clean it up. Okay? Clean it up. Just multiply this. 2 times radical 5. Keep it as a radical. So can we multiply the 2 and the 5 together? No. Because the 2 is not underneath the radical. The 5 is. So they are not allowed to be friends. So you literally just leave it as 2 radical 5. That's how it's going to stay in the bottom. What about the bottom? What's radical 5 times radical 5? Before we'll get to that sort of here in a second. Think what's 5 times 5? 25. This is square root of 25. If you can jump to that step, that's 25. Okay? So you multiply the top, multiply the bottom by radical 5. Now we need to simplify now. Can we simplify anything in our numerator? This is the top of our fraction. No. Can't simplify anything with the 2 and the radical 5. What about the bottom? Can we simplify the bottom? Yeah, what's the square root of 25? Okay. And then your third step, you're going to look to see, can I simplify my fraction? Can we simplify that fraction at all? Can the 2 and the 5 simplify? No. Okay. Really tempting to cancel out the 5s. Go like this, oh, let's cancel. Don't do that. Because again, the 5 in the bottom is not underneath the radical. The 5 in the top is. So they can't cancel. We'll put a plus next. I don't worry about that. I just when you simplify, just want you to have it writing it. When you do the square, things like that. You can get the process of rationalizing down. I'm not worried about the questions over there? Then you can't simplify the fraction, so just need. Oh. Any questions? Take a look at a couple examples, and then get time to practice. So when we rationalize, look, 3's got a perfect square. So how are we going to get rid of it in our denominator? Yeah, multiply in the top and in the bottom. So we multiply. What's 2 times radical 3? 2 radical 3. Very good. It's not radical 6. 2 is not underneath the radical. So we multiply in the bottom. 3 times 3. 9. Radical 9, we have a square root. Multiply top and bottom by the radical. Now we have to simplify our radicals. Can we simplify anything in the top? Oh, I just leave it as 2 radical 3. Can we simplify the bottom? Yeah, what's the square root of 9? Can we then check and see, can you simplify that fraction? Does 2 over 3 simplify? Again, the 3's don't cancel out because one's underneath the radical, the other one is not. They don't cancel. We take a look at B. Right? Again, how are we going to get rid of that radical in the denominator? Multiply by? 8. Good. Radical 8. Whatever's in the bottom.
Wait, in this case, you could just factor 3 the
You could, but it's just best to do it at the end. If it's a perfect square, take the perfect square root of it. If it's a non-perfect square, going to simplify at the end. So then 1 times radical 8 is just what? 8. And then 8 times 8 is 4. Top by radical 8, multiply the bottom by radical 8. Now simplify those radicals. Can we simplify radical 8? Yeah. So have to look and see what's the largest perfect square that can go into 8? 4. How many times? What's the square root of 4? 2. Can't take the square root of 2, so we tack it on at the end. Now, simplify the bottoms. What's the square root of 64? 8. Multiply top and bottom by the radical on the bottom, first step. Then you simplify your radicals. And then your last step, simplify the fraction. How can 2, fraction right here, how can 2 over 8 reduce? 1 over 4. And that radical 2 is still in the top. When you have a big fraction like that underneath your radical, again, I like to separate it. Like so. If you have a perfect square, take the square root of it right away. What's the square root of 16? 4. Clean it up even more. 4 over radical 7. Going to get rid of, and someone who has not said anything yet, the same Greek the whole time. How are we going to get rid of that radical 7 in the bottom? Grace? Good. Perfect. Multiply that radical 7 in the top. What's 4 times radical 7? Perfect. 4 radical 7. Not radical 28. And then what is radical 7 times radical 7? Radical 49. What's the square root of 49? 4 radical 7 over. You might be noticing a shortcut. When you do radical 3 times radical 3, it just ends up being the number underneath the radical. Radical 8 times radical 8 ends up being the number underneath the radical. Radical 7 times radical 7, it just ends up being the number underneath the radical. You're noticing that shortcut? You can go from here to here. Okay? And then simplify the fraction if you need to. You want to save yourself some time. That's fine. I know maybe you were doing that earlier, and that's totally fine. D, how are we going to get rid of that radical in the denominator? Yeah. Multiply the top and bottom. Okay. Well, when we multiply the top, that's radical 5 times radical 3. That's radical 15. Radical 5 times 3. Well, what's radical 3 times radical 3? Radical 9. What's the square root of 9? 3. So using that shortcut, when you multiply by the same exact radical, you just drop the radical signs and write the number 1. You need to do all the steps, then do all the steps. So that's the shortcut. Can we simplify radical 15 and 3? Does that become radical 5? No. Okay. Super tempting. 15 is underneath the radical, the 3 is not underneath the radical.